The cardiovascular system is a collection of organs that work together to ensure that blood gets to cells and tissues. Welcome to MedMinds, where we simplify medical knowledge. Before we get into the video, like and subscribe for more content like this. And while you're at it, don't forget to click on the notification bell to stay informed about more videos. Let's go. Yes, so as previously defined, the cardiovascular system is a collection of organs that work together to ensure that blood gets to cells and tissues. Welcome once again to MedMinds, and we'll be discussing the overview of the cardiovascular system under the above subheadings. Alright, now for the introduction. So the cardiovascular system is a system that includes the heart, blood vessels, and blood. So these can be classified as the three major components of the cardiovascular system. Now, cardio means heart, vascular means blood vessels. So the word isn't too big for you. Cardio is an anatomical suffix or anatomical word for heart, while vascular is that of blood vessels. It includes everything that concerns the heart, blood vessels, and blood. Yes, everything that concerns the heart, both its structure, its function, whatever has to do with the heart, the rhythmicity of the heart, and what's not, all of them are covered under the cardiovascular system, especially the blood vessels, their structure, their function, blood, its components, and all that. They are all captured under the cardiovascular system. Now, it's like the transport or delivery system of the body. Like, I don't even know which other analogy would best describe the cardiovascular system, because everything that needs to be where it needs to be just needs to be in the blood. Everything that needs to go where it needs to go just needs to be in the blood. So that is the cardiovascular system for you. Now, the cardiovascular system is very important because it comes in contact with all the organs in the body in one way or the other. This is so accurate, yes. Why? Because blood gets to every organ. So because blood gets to every organ and every organ needs blood, therefore the cardiovascular system comes in contact with every organ. Now, dysfunction in this system will affect all other systems. Yes. Now, am I trying to dispute the fact that dysfunction in other systems are not as serious as this? No, I'm not saying that exactly, but I'm trying to explain to you that any problem with the cardiovascular system is very detrimental, and it shows on time more than others. So this is a brief diagram of the summary of both systemic and pulmonary circulation, just trying to show the connection between these systems and then the organs. So now the heart, it is a hollow muscular organ, can be seen as a pump providing force needed to propel blood through blood vessels, because of course blood is not just going to be flowing by itself. I mean, we have gravity and everything working against this blood, so we need a kind of pump to push that blood through the blood vessels. And we said a problem with this organ can cause reduced blood flow to the organs, leading to death or dysfunction, just as you know already. This is the pump. So if the pump is not working, what that means is that blood will not be moving as it's supposed to move, as effectively as it's supposed to move, as efficiently as it's supposed to move. And what does that do? That stops blood from getting certain organs, causing tissue death and tissue dysfunction. Okay, now to the blood vessels. So number one, they are tube-like structures or organs that act like a conduit or passageway for blood. That one was pretty self-explanatory. Number two, it says they are of three broad types: arteries, veins, and capillaries. So basically, we have already understood that the cardiovascular system generally is like the transport system. And one thing about transport systems is they need a route. They need a particular way that they need to pass to get to where they need to be and deliver what needs to be delivered. Now, in the case of the cardiovascular system, we have been able to establish that the main component there that is doing the traveling is blood. Now, every other thing that is dissolved inside the blood is what the blood is carrying, but we are trying to explain now that the main component there is the blood, right? Now, blood is liquid. fluid, and so it must be, channeled by a pipe. So these pipes that channel the blood, is what we call the blood vessels. And we said here, number 2, that they are of 3 broad types, which are the arteries, the veins, and the capillaries, right? Now we go further to tell you in number 3 that arteries carry oxygenated blood, while veins carry deoxygenated blood, in exception with pulmonary veins and pulmonary arteries. So we've understood now that arteries and veins are all blood vessels. However, the component or the constitute of the blood they carry, whether it's oxygenated or deoxygenated, primarily differentiates them, right? So now an artery carries blood that has oxygen, while a vein carries blood that doesn't have oxygen. So ultimately we can say that arteries carry blood away from the heart, because most blood coming away from the heart is blood that contains what? Oxygen. Now this whole thing will make sense if you know blood circulation or blood flow through the heart. Now I think if you've not read that, I think you should go ahead and watch that video, because I've made that video, so to understand this concept. We were not saying that arteries carry oxygenated blood, veins carry deoxygenated blood, in exception with pulmonary veins and pulmonary arteries, right? Okay. Now number 4, say capillaries are the smallest blood vessels and are microscopic. So what that means is they cannot be viewed with the naked eye except with a microscope. So basically, in the structure of the arrangement, capillaries are in between arteries and veins, and they are the main site for the exchange of those components of the blood, both the exchange of oxygen and nutrients, and then the exchange of waste products between the cells and the blood, right? Now number 4, a problem in any vessel will directly or indirectly affect the organ or structures they supply. So like we've already established that these blood vessels are responsible for either supplying or draining blood from a particular organ, and most times you can even find out that there are particular organs that are only supplied by a particular branch. So you can see that if there's any problem in the branch of that artery or branch of that vein, that organ will suffer, except maybe cases of anastomosis where there's another blood vessel that can supply that organ. But if it happens that there is no other blood vessel that can supply that organ, it could be very detrimental. Cool. Now we're going to look at the structures of these blood vessels up close. This diagram isn't really detailed, but it's an overview. So you can see here we have artery, a vein, and then the capillary, right? Now you can see the arteries here are red, veins are blue, and then you can see the capillary is a mixture of the both, right? Now an anatomist once told me that the arteries and veins don't actually have this kind of varying difference in colors in real life, like in an actual vein and an artery, but in most diagrams, anatomical diagrams, it's presented this way for better understanding because they are similar. It's only when you go deeply then you can now understand the difference in their structures. So if you look at where the capillary comes in, right, you can see this red blood vessel and you can see the blue blood vessel, which are the artery and the vein respectively, and how they come together to kind of form the capillary. And then you can see that those minute or smaller branches of that main artery, you can see as it's coming out, they call it the arteriole that is about to form the capillary, right? Then if you now look at the other minute branches coming from the vein, they call them the venules, right? Coming together to form the capillaries. So you can see that this is a highly organized network where the capillaries are a tuft of blood vessels that are formed by the arteries, smaller branches of the arteries and smaller branches of the vein. And guess what? The capillaries only have a single layer of endothelium. They are so leaky. They are so the space between them is so much in the way to ensure for fast and rapid exchange between the body cells, the body tissues, and the blood, both receiving waste products into the blood for disposing and then giving of oxygen, giving of glucose, and all of those things to the cells. Okay, now the blood. So number 1, this is a fluid connective tissue, much like the fuel in a car. Yes, it's needed for the car to run. Number two, it contains nutrients that are needed by organs and structures in the body. Of course, it contains all sorts of nutrients. It contains even the blood cells, the cells that do a lot of things in our body, that the red blood cells that are mainly involved in the transport of oxygen, and so many other things, even plasma that contains the albumin, the fibrinogen, which are all these clothing factors that help in hemostasis, which is cessation of bleeding. Number three, it is also a gutter or sewer where waste products like carbon dioxide from cells are transported to the kidney where they'll be excreted. Of course, yes, they also act as a sewage. They act as a draining mechanism, a draining function, an excretory function in a way, Number four, it's if blood composition is compromised, or if there is an obstruction keeping blood from getting to an organ in the body, it could cause tissue hypoxia or shock, amongst many. Very, very, very true. Very true. If there is an imbalance, or if there is a deficiency in any of the components of the blood, it could be very, very detrimental. Remember that this blood, we said, is coming in contact with almost every organ in the body, and if there is any problem in it, the cells won't be able to get what they need to get, and this could cause so many things like tissue hypoxia, which is where there is not enough oxygen being supplied to tissues, and shock. For the summary, the CVS is a key system in maintaining homeostasis, which is equilibrium in the body, though other systems are also very important. Number two, the heart is the pump, the blood vessels are the pipes, and the blood is the flow. All you need to do is remember these three things. Then number three, the three main blood vessels are arteries, veins, and capillaries. Good. Number four, blood is a fluid connective tissue. I really don't know if I did justice to this, but I am so sure that if you go through this video, you will be able to walk through all your class notes and handouts without fear, without confusion. It will basically form a foundation and a basis for your understanding. Thank you so much for watching. Always remember to like and subscribe and turn on your notification bell, because we're going to be dropping more videos like this so you can watch and catch up. Thank you so much once again. Love you guys. Bye.